The cosine rule for finding unknown sides and angles. Every time we do trigonometry, we label our sides. If we're going to be finding side x, we might as well make that side A and the angle opposite angle A, because that way it will let us use the most friendly version of whichever rule. And then we have angle B and C on this example, which we don't know, and we'll label our opposite sides C and B. Once we've labelled our triangle, we always check which rule we're going to use, which means we check which set of criteria we have. I don't have a side and an opposite angle, so it rules out our sine rule, but I do have two sides, B and C, and the included angle, A, so I can use the cosine rule. We write the cosine rule for finding sides. If we get a little bit confused, you can always pop a little times sign in between 2bc cos A, so it's minus 2bc times cos A, up to you. So we're finding x squared is side B squared plus side C squared minus 2 times 7 times 6 times cos of angle A, which is 80 degrees. Now you do have two options. We've got x squared there and we'd like x. You can put that whole lot in brackets and find the square root, or you can evaluate the whole lot and then find the square root. I find a lot of people find it easier, since we've got to type this in anyway, just to find the square root of everything in that above line in brackets. But assuming that we've evaluated that, x will be the square root of 70.4136. So square root of 70.4136, and we're 8.39. So x is 8.39 centimeters. If you'd preferred, though, instead of evaluating, which I didn't, you know, we had to do 7 squared, oops, and you know that's silly because that's 49, we know that. 49 plus 6 squared is 36, minus, so you can keep on working all of this out if you want. 2 times 7 times 6 times cos of 80. Fine to keep on working all that out and then find the square root of it, or fine to start by saying, well, let's do the square root of, put the whole lot in brackets, and then do 7 squared plus 6 squared. If we're leaping ahead, we know that 6 squared is 36, plus, oh no, minus. So you can enter it all in under the square root sign like that, which does tend to make life a little bit simpler. And I'm just going to hit and give up on that one because we've worked it out. But you've got a couple of options. Come on. Now, before we did this, I really should have checked that we were in degrees mode. I did know I was, but yep, there I am. So for finding an unknown side, we do end up with this nasty long sum that we have to do. Might as well just pop it in under the square root. For finding an unknown angle, so here, find angle B. Label our sides opposite the appropriate angles A, B and C, and we choose the version of the cosine rule that gives us an angle. So that's going to start with cos, and because we're finding angle B, we should probably start with cos B, but if you don't write all the versions down, that's okay. A squared plus C squared minus B squared over 2AC. Double check, of course, that we have three sides. Yes, we do, so we can find an angle with the cosine rule. Substitute your values in. Nice, easy one for this. Because 4 squared plus 6 squared minus 6 squared is 16, and we're over 2 times 4 times 6, 48. So we've got to a very nice fraction that's cos of our angle. And then, of course, if I've got cos of the angle and I just want the angle, I need to do inverse cos. Might as well just leave that as a fraction. Running out of space again, I'm sorry. And inverse cos, in brackets, we've got 16 divided by 48 and again we're finding an angle. I've got 70.5 degrees, but second function angle and DMS to give me 70 degrees 32 minutes, or B equals. So again, label your sides and angles, check that you can use the cosine rule, write the rule, substitute your values, and solve. Remember, when you're solving to find an angle, inverse cos.